Hey, ladies and gentlemen, this is Miss Humbert, and I'm going to be finishing up Unit 8, Note 6 for you here. So let's start by taking a look at that word problem number 5. It says that Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. So let's first kind of draw that out. So here's the cup that we're aiming for right here. Okay, and it says that she's 20 feet short, 20 feet short, and 8 feet to the right. Okay, so 20 feet short and 8 feet to the right. Let's call the cup the point 0, 0. Okay, so that's going to be at the point 0, 0. Well, if that's 0, 0, I just went down 20 and over 8. Okay, then she hits it and it lands 2 feet to the left and 3 feet beyond. So we went 2 and 3. And that's where we were later. Okay, now whenever you go left, that's negative, and up is positive, just like we went down for 20, so I made that negative 20. So now we got the points for this golf ball, okay? So we were 20 feet short and 8 feet to the right. That's what gave us this point. 2 feet to the left and 3 feet up. Once we hit it, that's what gave us that point. So now we're going to go ahead and we're going to calculate the distance between those points. So I'm going to do x2 minus x1. So sometimes it helps me to label out those points. So I'm just going to call this one x1, this one y1, this one x2, this one y2. So I'm going to plug that into the formula. So I have y2 minus y1. I'm subtracting a negative, so that's going to become plus a positive, and I'm squaring it. And then I have y2 minus y1, and then I'm squaring it. So I'm going to go ahead and I'm going to simplify this. So I have negative 2 plus 20. That's going to give me a positive 18 squared. Then I'm going to have 3 minus 8. That's going to be a negative 5 squared. So when you're squaring the negatives, that's where that parentheses becomes really, really, really important. Okay, so 18 squared is going to give me 324. Negative 5 squared is going to actually give me a positive 25. So then I'm going to write that out, and then I get the square root of 349 feet. So far, let's see if we can reduce that. So I'm just going to try dividing that by certain numbers. See, so I tried dividing it by 3, that didn't work. 349, tried dividing that by 7, that didn't work. So I'm not able to find any pairs for that. And if you don't believe me, you can go ahead and try a little more on yourself. So that is my fully simplified radical. So then I label it feet, and that's my answer. So it landed the square root of 349 feet away from where we started hitting it. Okay, let's take a look at number 6. So for number 6, on college campus, she has her first class in Rhodes Hall and her second class is in Fulton Lab. How far does she have to walk between her first and second classes? Well, here that gives us the undergraduate library. Let's make the undergraduate library at the origin. So we're going to call that the origin. So from the origin, or the undergraduate library, Rhodes Hall is 1/4 of a mile. So we're going to go left 1/4 of a mile. That means negative. We didn't go up any, so that's just going to be 0. So that point is negative 1/4 and 0. Fulton Lab, we went left 1/8. Okay, so our x-coordinate is, right 1/8. Our x-coordinate is always how far we went over, even if that's not what we do first. So we went right 1/8. Excuse me. And then we went down 3/8, so that's going to be negative. So now we want to calculate the distance between those 2 points. So I'm going to go ahead and I'm going to assign my x1 and my y1. So I'm going to call this one x1, y1, and this one x2, y2. And I'm going to go ahead and I'm going to calculate that out. So here we have x2 minus x1. Oops. So we have x2 minus x1. Remember, when you subtract a negative, it becomes plus a positive. And then y2 minus y1. So here's the tricky part, okay? So we have to think about how we're going to add those fractions. So we have 1/8 plus 1/4. Okay, well, 1/4 I could actually write as 2/8. Because if you reduce the fraction 2/8, you would end up with 1/4. So then we're really going to do 1/8 plus 2/8. Well, that's going to give us 3/8. Remember, when you're adding fractions, you don't add the denominator, you just add the numerator. So we're going to square that. And then again over here, we're going to have 3/8 squared. And even though it's negative, when we square it, it's going to become positive. So then when you square fractions, you have to square both the top and the bottom. So then I end up with 9/64 plus 9/64. Well, let's add those up. We can add the top together. So then I end up with 18 over 64. Okay, we've simplified stuff like this before. So what we need to do is split up that fraction. I'm going to write it as the square root of 18 over the square root of 64. Well, the square root of 64 is just 8. And so then I'm left with the square root of 18 on top. So I need to simplify that square root of 18 down a little bit. So the square root of 18, we're going to get 9 and 2. And then we're going to break that 9 down to be 3 and 3. Okay, so I have a pair of 3's that I can pull out. So I'm going to go ahead and do that. So I'm going to write this as 3 square root of 2 over 8. Well, the fraction 3 over 8 can't be reduced anymore, so this right here is our final answer. Last thing we need is a label, which is going to be miles. So that's the distance she has to walk from Rhodes Hall to Fulton Lab. Let's take a look at how the distance formula is derived. So let's just pick a point. Okay, so I'm going to say, okay, I'm going to try and I'm going to go for the point 6, 0. So I'm going to go to this point right here. So I'm going all the way from the origin to this point. Okay, then I'm going to go to the point, let's say 0, 4. So I'm going to go all the way up to this point. And then I want to calculate the distance between that point. Now you might be noticing something really familiar right now. Hopefully you're looking at that and you're thinking to yourself, hey, that is a right triangle, because you're right, it is. Okay, so this is the point 6, 0, and this is the point 0, 4. Well, here's the fun part. Okay, this is going to blow your minds. The distance formula is the exact same as the Pythagorean theorem. Don't believe me? Let's take a look. So this distance is 6 horizontally. This distance is 4 horizontally. Let's start by calculating the distance between those 2 points using the distance formula. So we're going to have x2 minus x1, and then y2 minus y1. So then we end up with 6 squared plus negative 4 squared. So that gives us a square root of 36 plus 16. And then that gives us the square root of 52. So we're going to go ahead and simplify that down. Square root of 52, I can break down to 4 and 13, and that breaks down to 2 and 2, so I can take out a pair of 2's, and I'm left with 2 radical 13. So calculated by the distance formula, the distance between those two is 3 radical 13. Well, let's try and calculate it using the Pythagorean theorem. So what we're looking for is this distance here. Okay, so we're looking for the hypotenuse. So let's go ahead and calculate that out. So we have 4 squared plus 6 squared is equal to x squared. Well, 4 squared is 16, 6 squared is 36, and that's equal to x squared. So to solve for x, we're going to take the square root of both sides. So I get that x is equal to the square root of 36 plus 16. Well, hey, what does that look like? It looks like that right there. Okay, so that's how they're related. You're really doing the same thing. So sometimes you read word problems and you think to yourself, oh, this would be so much easier with the Pythagorean theorem. And that's true. Okay, you can use the Pythagorean theorem on a lot of these that you're using the distance formula on. So feel free to do that. Let's take a look at number 7. It says find the possible values of A if the distance between the points 7, 5 and A, negative 3 is 10 units. So let's go ahead and calculate that out. So I'm going to call this one x1, this one y1, this one x2, this one y2. So we're going to calculate the distance between those 2 points. So I have y2 minus y1, or x2 minus x1, sorry, and then y2 minus y1. And I know the distance between those 2 points is 10. So I'm going to use that to my advantage. So now I have a minus 7 quantity squared plus negative 3 minus 5 is negative 8. Oh, negative 3 plus 5 because we're subtracting a negative. So that there should be 2 squared. And then we get the square root of a minus 7 quantity squared plus 4. And now remember that's equal to 10. So now I have that radical completely isolated on one side, and there's a variable underneath it that I want. So what I'm going to do is I'm going to go ahead and I'm going to square both sides. Well, when I square the left side, I'm left with a minus 7 plus 4. This is squared. And that's equal to 100 because 10 squared is 100. So I'm going to start and I'm going to subtract 4 from both sides. Okay, so when I do that, I'm left with a minus 7 quantity squared is equal to 96. So now I see that that squared term is completely by itself. So now I'm going to take the square root of both sides. So I'm doing kind of a little bit of both. So then I'm left with a minus 7 is equal to the square root of 96. Well, let's go ahead and break down the square root of 96. To break down the square root of 96, we can get 16 and 6. Well, 16 breaks down to 4 and 4. 16 breaks down to 2, or 6 breaks down to 2 and 3. So that doesn't really help us. But we can take out the pair of 4. So we have a minus 7 is equal to 4 square root of 6. So now to solve for a, I'm going to add 7 to both sides. And then I'm left with a is equal to 4 square root of 6 plus 7. Remember, I can't add those two terms together because they're different. There's different radicals, so I can't add them together. Last but not least, let's take a look at number 8. So we're going to do the exact same thing. So I'm going to do y2 minus y1, and then, or sorry, that was x2. So that was x2 minus x1, and then y2 minus y1. And we're going to set that equal to the square root of 58. So let's go ahead and simplify this down some more. So to do that, we get negative 7 squared plus 5 minus a squared is equal to the square root of 58. So then I get the square root of 49 plus 5 minus a, quantity squared, is equal to the square root of 58. Now I have two radicals on either side, but technically they're both isolated. So at this point, I can go ahead and I can square both sides. So I'm going to do that. And then I'm left with 49 plus 5 minus a squared is equal to 58. When you square a square root, you're just left with what's underneath. So I'm going to simplify that some more. I'm going to go ahead and I'm going to subtract 49 from both sides. Okay, so then I get 5 minus a, quantity squared, and 58 minus 49 is going to give me 9. Now I want to get rid of that squared term, so I'm going to go ahead and I'm going to take the square root of both sides. And when I do that, I'm left with 5 minus a, and then the square root of 9 is 3. So now I'm going to subtract 5 from both sides, and I get the opposite of a is equal to a negative 2. Well, I don't want to know what the opposite of a is. I don't want to deal with that negative a, so I'm going to divide both sides by negative 1. And when I do that, that's going to turn it into a positive, so I get that a is equal to 2, and that is your final answer. Thanks for listening.